Hi, welcome back. So in this video, we're going to talk about special angles and reference triangles. So at the end of this particular series of videos, our goal is going to be to know the sine and cosine value for a set of special angles. So when we have our circle on our axes, we can divide the circle into 4 quadrants. So we often refer to which quadrant an angle is in, and for now we're actually just going to focus on the first quadrant. So we label our quadrants counterclockwise in the way that we would draw out an angle in standard position. So we have Q1 in the upper right quadrant, that's quadrant 1. Then we have quadrant 2, that's in the upper left quadrant. Then we have quadrant 3, Q3 in the bottom left, and then quadrant 4 in the bottom right. So as I mentioned, we're going to focus on quadrant 1 first, and then we will be able to use some symmetry to talk about the other quadrants. So let's look at our first quadrant. We start at 0 degrees, which is 0 radians, and I'm also just keeping it in mind that one full rotation, if we ended up all the way back, would be 360 degrees, or 2 pi. Then a quarter of the way around the full rotation is 90 degrees. So 90 times 4 gives us that 360. So a quarter of the way is 90 degrees. And this corresponds to pi over 2 radians. So that's 2 pi divided by 4, pi over 2. Now we're going to look at 3 special angles in this first quadrant. We're going to start with 45 degrees, which is halfway between 0 and 90 degrees. This corresponds to pi over 4 radians. So you can think of taking pi over 2 and dividing it by 2, we'd get pi over 4. Now we're also going to consider some multiples of 30, so we'll look at 30 degrees, that's pi over 6, and 60 degrees, that's pi over 3. So you can think of taking pi over 2 and dividing it in thirds. We'd get pi over 6, and that's our 30 degrees, and we would do another one of those 30 degrees to get up to 60 degrees. So these are the angles we're going to start with, and these are our special angles. So remember, on our unit circle, that's a circle with radius 1, our points on the circle are actually that x is cosine and y is sine. So we're looking for these cosine and sine values to tell us the coordinates of the specific points relating to these special angles. We start by just looking at these special angles because it's a subset of the angles for us to look at and helps us just get acquainted with the idea of sine and cosine and what they do. So in order to determine the sine and cosine for these special angles, we're going to need something called reference triangles. So in this video, I'm just going to explain where these reference triangles come from and why they are what they are. So I could just hand you the reference triangles and be like, hey, this is true. And you could be like, cool, Claire, thanks, I'll take that and go. And if that's what you want, that's fine. In the next video, I'll review the triangles briefly and go from there. But I think it's nice to know where the triangles come from, and actually, if you follow through this, you could derive this on your own. If you're ever out in the wild and you don't remember the triangles, you can go through a little proof to come up with them. So we're going to start with our 45-degree angle, or pi over 4, and create a reference triangle for this angle. So again, we're making these triangles. You might not really know what they're used for yet, but you'll see it in the next video. So if we create a triangle from our angle by drawing a line down to the x-axis, we have our 45-degree angle, we have a right angle, and we know our hypotenuse is 1 because we are on the unit circle. Then we're trying to determine the other side lengths. If the angle is 45 and the length of the hypotenuse is 1, what are these side lengths? So we're going to derive this. We're going to basically find them using some geometry. So I'm going to label the sides x and y, and because both angles are the same on this triangle, because it's 45, 45, 90, this is an isosceles triangle. So that means that the side lengths x and y are equivalent, they're the same length. So why that's true is really part of a geometry class and not what I'm going to go through right now, but the idea is this is isosceles, so we know that x is equal to y. I'm going to relabel my side that said y as x, and now I'm going to use the Pythagorean theorem to help me solve. So the Pythagorean theorem says that a squared plus b squared equals c squared, which here is just x squared plus x squared equals 1 squared. Then I can combine like terms. I'm getting 2x squared equals 1. I'll divide by 2. Remember, I'm trying to solve for x. So I'm getting x squared is equal to 1/2. And then to solve for x, I'm going to take the plus or minus square root of 1/2. Now, because we're looking at side lengths, we're really going to assume that this length is positive. But if that doesn't make you all that happy or you're not super sure, you can think back to our circle. We're going over some positive x value to the right, and then up some positive y value to get up to our point, because we're in this first quadrant. So we know this x value needs to be positive, so I'm going to take the positive square root. This tells me that the length of my sides are both the square root of 1/2. So I don't really like how the square root of 1/2 looks, especially since I know the square root of 1 is 1. So we're going to simplify this into something that looks a little better. So when we have the square root of 1/2, we can rewrite it as the square root of 1 over the square root of 2. Then the square root of 1 is just 1, so we have 1 over the square root of 2. And now we're going to do something called rationalizing, where we multiply both the numerator and the denominator by square root of 2. We're allowed to do this because we can multiply by 1 anytime we want and keep what we have the same. So we're going to multiply by square root of 2 over square root of 2. And so we're left with a new fraction, which is square root of 2 over 2. And that happens because when we take a square root times a square root, the square roots undo each other and we end up just with what we had left over. So square root of 2 times square root of 2 is just 2. So I'm going to relabel my sides as square root of 2 over 2 and square root of 2 over 2. And that's it. This is our reference triangle. So we could say our reference triangle for 45 degrees and pi over 4 is this triangle with square root of 2 over 2, square root of 2 over 2, and 1 as its sides. And remember, our whole goal with this is to ultimately determine the sine and the cosine of our angle of 45 degrees or pi over 4, and this is going to help us determine the coordinates of the point on the circle. But that happens in another video. So we're going to repeat this same process for our 30 degrees and our 60 degrees, and these are actually going to use the same triangle. So you'll see why in a moment. So this is our 30 degrees, which is our pi over 6, and 60 degrees, which is pi over 3, reference triangle. I'm going to leave my 30 degrees as my angle on the left, and then I'm actually noticing that my angle on the top is 60 degrees. We know the angles of a triangle add up to 180 degrees, and so I know that if one of them is 90 degrees and one of them is 30, then we need 60 in order to add up to 180. So just a reminder, you don't need to know all of this right now, but I'm just referring back to some other mathematical ideas you've probably learned before to remind you of what you already know and just give you some ideas of where these triangles came from. So I'm actually going to just give you the triangles in the next video. You don't need to know how to come up with them on your own, but I think it's really cool and I think it's just a good mathematical skill, so that's why I'm showing it to you. But please don't panic if you're like, Dr. Claire, I don't remember this. How do you know these things? That's okay. We're learning new stuff, and the important thing is that you can see the triangles in the following videos and use them with our new skills. Okay, so I have my angles, 30 degrees and 60 degrees. I could write these as radians, but I'm going to keep them in as degrees because it's just easier for me. And the hypotenuse is 1, and I'll label my sides x and y. So in order to determine these side lengths x and y, what I'm going to do is actually make an even bigger triangle. So I'm going to mirror this triangle on itself, and so now I have a bigger triangle which has all of its angles equal to 60 degrees. So that's because I've taken that 30 degree and doubled it, so I have 60 degrees, and I've mirrored that 60 degrees down, so I know they're all 60 degrees. Now, this is another geometry fact that we're going to use, but because all of the angles are equal, this is an equilateral triangle, which means that all of the sides are equal. So I know that 1 is equal to y plus y, because the side lengths have to all be the same. And so given this, I can solve for y. So here I get y plus y equals 1. Combining terms, that's 2y equals 1. And to solve for y, I divide by 2. So I get that y is equal to 1/2. And we like this information because now we know in our original triangle that y is 1/2. Remember, our goal is to find these side lengths. Now, because we only have one side left, we can find x in our triangle using Pythagorean Theorem. So I set up x squared plus 1/2 squared is equal to 1 squared. That's a squared plus b squared equals c squared. Now I solve for x, so 1/2 squared is 1/4, 1 squared is 1. I'm going to isolate the x by moving the 1/4 over to the other side. 1 minus 1/4 is like doing 4/4 minus 1/4, which is 3/4. And so I have x squared equals 3/4. Now I'm solving for x. I'm going to take the square root. I'm going to take the positive square root for the same reasoning as before on the 45 triangle. And so I'm getting the square root of 3/4, which I can then simplify. So we found the x. I'm just going to make it pretty really quick. So I'll take the square root of 3 divided by the square root of 4. And since the square root of 4 is 2, we're getting that x is equal to the square root of 3 over 2. And now we found both of our sides. So we are going to say that our reference triangle for 30 degrees and 60 degrees has these side lengths. So the 1/2 is across from the 30 degrees, and the square root of 3 over 2 is across from the 60 degrees, with the hypotenuse being 1. So if we needed to use this triangle for the 60 degrees or the 30 degrees, we would just position ourselves sort of at that angle, and we can use the same triangle since both angles are present on it. Okay, so we have 2 reference triangles that we're going to use to help us with sine and cosine as we move on to the next videos. Thanks so much for watching, and I will talk to you in the next one.